Hello, and welcome back to another episode of Game Dev Security. In this episode, we're going to be looking at how we can mitigate against what is known as a replay or a mirror attack. Just to give some context on what this attack actually involves, let's go back to episode 1 in the series, where Salima made an insecure game. So just to reiterate what was wrong with this game, the game stored the state of the game on the client. So as we know, this game is a Flappy Sats game. Like Flappy Bird, as the player taps the screen and the bird flies through the pipes, the score increments by 1. So what Salima was doing is she was storing the score on the client, which means that Daniel, our in-house attacker, could edit the client, save data or the memory and update his score. To mitigate this, in episode 6, Salima basically moved everything over to the server. We used PlayFab for this. However, you can use other solutions such as Firebase or Beamable or even your own server, which I recommend if you have the resources. But basically, instead of keeping track of the score on the client every time the bird went through the obstacle, we told PlayFab that the bird had gone through the obstacle, and we incremented the score on the server. And that is the correct way to do it. This is called a server authoritative game. As much as possible, you want to move the gameplay over there. However, this is not a silver bullet, and if we go to episode 5, towards the end, Daniel was showing how you can basically mirror or replay this request to PlayFab, thus incrementing the score. So rather than just sending the score to PlayFab, where Daniel could literally edit the data and save data in memory, or actually edit the data on the network level, actually just going in and intercepting the HTTP request and editing the payload. Because we don't actually send any data, we just send the event that the player went through the obstacle. He can just literally replay that. So if he replays it 10 times, the server thinks the player went through the obstacle 10 times and the score increased by 10. So I recommend taking a look at that video just to give it a context. Anyway, this is known as a replay or a mirror attack. So today we're going to look at some ways that we can mitigate this type of attack. So here's a little diagram to show what a replay attack is. The user is sending data to the server, and then the attacker, in this case, we need to confirm that the attacker is actually the user. The user is hacking their own game. The user sniffs the packet, the communication, and just replays it exactly. So how this is generally dealt with, we need to make sure each request is unique. And if the same request comes in twice, we reject it. So in the instance of a replay attack, because it's literally mirroring the attack, the request is exactly the same. So we can make sure that the request is different by adding a random number, what is known in cryptographic terms as a nonce, a number used only once. And this means that each request has a different random number, and so the server expects a request with a different random number each time. If it sees a request with an existing random number, it knows that this has been replayed or mirrored, and it can block or ban the user. So let's look at how we can update our code to do something similar. So I head to the project. So this is on security branch 3 on GitHub. And let's look at the function that is called whenever the player goes through the obstacle. So update player score. So this is basically called every time the bird flies through the pipes. And we've just added a function parameter here called proof, or called payload, and the variable name is called proof. So then on the PlayFab side, we are in our cloud script, we edit our cloud script, and we get this args.payload. And so let's have a deeper look at what we're actually doing there. So we have this function here called create proof. It's in Game Manager, and now there is a few things here around encryption. We're going to talk about that in the next episode, but for now, let's just focus on this line here, which is a random nonce. So we're basically generating a random number. We're using the default C# function new GUID, which will give us a reasonably random, unique. We can be sure that the data will be different each time. And we're basically returning that. Again, ignore this encryption stuff. That's to talk about in the next episode. And we'll return that as the payload, and that's sent to our function. In our function, we receive it here. And we are basically checking if we have received this before. So the first time we have not received this before, so we basically save this nonce into the player internal data. And then the second time when the nonce comes in, we check, does this nonce exist in our player data? If it does exist, we set a cheated flag to true. And then if the cheated flag is true, we just return an error saying, please contact support. So let's just see this in action. I'm just going to find my player here. I believe I should have some existing data already. So let me just get rid of that so we can start with a clean slate. Okay. So we can see the score is incrementing, and we should have some nonces in our player data. Yeah, we got some nonces have come through now. So each time the request comes in, we are saving this random piece of data. Okay, so now let's try and emulate what happens if a replay attack actually happens. So in the case of a replay attack, the same nonce would come in more than once. To easily just emulate that, we can go into our function and just for now return the exact same nonce. Let's click 1, 2, 3, 4. Now, when this comes into our cloud script, the first time it should be okay because no nonce exists. But the second time, the nonce should already exist and we should set cheated to true and we should get a please contact support error. So let's try this. So we can see the score stopped incrementing. And if we go to our log, we can see please contact support has been returned. And if we head to our player data, we can see only one nonce came in and cheated was set to true. That's basically as simple as it is. This is a common way to stop these replay mirror attacks. Just a few caveats here. Unfortunately, PlayFab does have some limitations. We are unable to... You can't store too much data. So generally, if you are running your own server, you might store thousands of requests. So you can basically kind of check, in the past against thousands of requests if the nonce has been reused. However, PlayFab doesn't let you store that much. There is a limit. So just to make sure we don't kind of hit that limit, I added we added a few things. The nonce is saved with a timestamp. We can see here. And then we run a function called cleanup, which basically gets rid of any nonces which are older than 60 seconds. And also PlayFab only lets you delete 10 at a time. So that's just a small caveat there. Again, if you really want to have the best security, sometimes it's better to use a combination of PlayFab and also your own server where you don't have these limitations. But that's what this code is there. Okay, so just to finish up, I also want to mention another caveat. So we can see that we are actually doing some encryption here. And the reason is when we send the nonce to our PlayFab function, technically, as shown in episode 5, it is possible for the hacker to edit data sent. So the hacker could, before he replays the attack, he could change the nonce himself. And that way he wouldn't be playing the game, he would be manually or even automatically with a script replaying the attack and changing the nonce each time. So this kind of goes into a more fundamental thing about security is how do you know that when your game sends data to your server that the data hasn't been tampered with? And this is known as something in the security world as certificate pinning is one way to handle it. We're going to look at something similar in the next episode to see how we can stop an attacker from changing that nonce. Okay, so thank you for watching and I will see you next time.